do in your assessment is to identify unknowns. And you might know that they're one ion or another, and you just have to prove which one they are with equations and observations. However, there's some where we're not going to give you any clues at all, and you have to tell us which anion or which cation is there, or maybe both. And that's what you need to be able to use those flowcharts on page 46 and 47 to do. So what I'm going to do is just show you a couple of things we can do with it, and then how we justify those and go from there. So what I've grabbed are some chemicals I'm going to need for testing, which is sodium hydroxide, sulfuric acid, and ammonia. They are the main ones that I'm going to need. I could also have potassium thiocyanate, which will give me an opportunity to do a complex ion one. So if we get one that could be iron 3+, I'll grab that then. Right, so the first hint I'm going to give you is to use very small volumes. So the first thing I've got, I know what it is, I know it's aluminium sulfate, but I'm going to prove that it's got aluminium ions in it. So it's just a small amount in the bottom of a test tube, so just that amount there, so less than a centimetre. Then if I follow the flowchart, the first thing it says is add 2 drops of dilute sodium hydroxide solution. So I've got that here, I'm just going to put a couple of drops in. If you do too much, you might get the wrong result. And we see that it goes quite cloudy. Okay, can you see that? Probably not there. If I put it in front of my shirt or my hand, you can see it's gone milky. If it goes cloudy, that means it's precipitated. It means that there's a solid in there. The particles are too small for us to see each one, but there is one there. So that means one of those ions has reacted with sodium hydroxide. Well, I'm testing for cations, so it must be the cation. So what I write for that is that the aluminium ions, which are Al3+, so I don't have to worry about the sulfate. I just put in the ions that are reacting. Plus the hydroxide from the sodium hydroxide are reacting to make aluminium hydroxide. Now it's 3 OHs to make the charges balance out. 3 pluses, 3 minuses now. To balance the equation, I therefore need 3 there. I've now actually justified that, so I've now shown with my description, I've now shown that I've got an understanding to merit level in this question. The next question, if I go down here, it says white precipitate. It is lead or aluminium or zinc or magnesium. It now says to add excess. So what that means is you're basically going to double the volume of what's in there. So add excess sodium hydroxide, and this isn't a dilution, it's actually gone completely clear now. Okay, you can see that there's no cloudiness in there anymore. So what we say is that the precipitate disappeared or redissolved. If something has changed, and it has from solid to solution, if something has changed, then a chemical reaction must have occurred. Again, I know it's aluminium, so I can write this. Aluminium, sorry, I put the wrong one there. The aluminium hydroxide, which is my solid, has now reacted with more hydroxides, and it makes a thing called a complex ion. So it's making something that other hydroxide has gone in there to give the whole thing a charge. So you end up with a square bracket, because there's going to be curved brackets inside it, so that's why I put a square bracket around it. Aluminium, and now there's 1, 2, 3, 4 hydroxides there, which means this whole thing must have a charge, because aluminium is only 3+, and there's 4 negatives. So 3 minus 4 is -1, so that's its charge. And that thing is water soluble. It'll disappear, which is exactly what we observed. It disappeared in that solution. Remember, that's mainly water. The ions are just present in there as well. It's mainly water. I still don't know it's aluminium though. I still wouldn't know it's aluminium if I didn't know which one it is. It could be aluminium, or it could be lead, or it could be zinc, because all of those make these complex ions. They all do it. So now what I need to do is get a new sample, and remember, just a small amount. And what I'm going to do with this one is I'm going to add sodium iodide or potassium iodide, our next step in our flowchart. I'm going to use potassium iodide just because it's available. And again, it's just a few drops. Don't go hard on it. And if I shake that up, I can see nothing forms. There's no change. So I don't write the chemical equation. Nothing changed. So I don't need to. Okay? If there's no precipitate, it says it's aluminium or zinc. So this is still what I know, so that's good. It says get a new sample. So another test tube, another small amount. And now it says add a few drops of ammonia solution. Now ammonia solution is a base, which means it's got hydroxide ions in it. So with a few drops, I hope it's going to make it precipitate. And it does, it goes cloudy again. Okay, you might be able to see that there. It's gone cloudy. So what this means is that it's done this reaction again, making the aluminium hydroxide. Okay, that's what that is. It happens because ammonia is a base, which means it's got hydroxide ions available. Alright? But if I add excess of it, it might disappear. So I put a good squirt in it and actually it just got worse. It precipitated even more. Okay, so that means it didn't disappear. It smells a bit now. If it did disappear, then I was wrong. It wasn't aluminium, it was zinc. But it stayed there, so it's still really cloudy. So that means it definitely is aluminium because it can't make a complex ion with ammonia. Alright, so you can see I've had to do 3 different test tubes, 3 different sets of results to prove that that is aluminium, but I've only needed 2 equations for that because there was only really 2 changes. Alright, right, I'm going to show you a different one. I'm going to show you one where there is a coloured iron.
Sure.
Yes?
What was the reaction between these, the aluminium and the NH3?
Oh, still the same as this first one because the NH3 is actually, it's a base, it's in solution, so it's got hydroxide ions. Okay?
Do you think you'll be able to show us an example where we don't know what the
I'm not going to tell you the next one, yes. Okay, I'm not going to tell you what it is and we'll go through it.
Why can't aluminium make a complex ion with ammonia, but it can with other solutions?
It's to do with the strength of the bonding between the aluminium and what are called ligands, so the hydroxides or the ammonia or the water. It's just not strong enough. So it's
kind of what you
more
explained
stable
yesterday.
for it to be that than to have ammonia in.
Okay, sweet.
Right, now I'm going to take one that I'm not going to tell you what it is. This stuff here. We'll go through the same process. So my first thing is a small amount. Whoops, I actually probably put a bit too much in that, to be honest. Right, so small amount in there. And the first step is to add sodium hydroxide. Just a few drops. And it's gone cloudy. So what are the possible ions there, looking at our flowchart?
Lead, aluminium, zinc, magnesium.
Great, lead, aluminium, zinc or magnesium. Then it says to add excess, and I do that. And is it still cloudy?
Yes.
Yeah.
Okay, I'll give it a shake just in case. No, it's still cloudy. So therefore I know straight away which ion it is. It must be magnesium. I prove it, I justify it with an equation. It's only the magnesium that reacts, not whatever ion is in there. We haven't worked out the anion in this. Reacting with the hydroxide from the sodium hydroxide, so I'm getting rid of the spectator ions. Now to do the balanced formula for this, 2 plus means there needs to be 2 of those, the 2 minus, which means I need 2 there.
Wasn't it NaOH? Is it?
It was, but the sodium's not reacting, just the hydroxide. Good question. This is the NaOH, I'll write that underneath it. This is the NaOH here.
But the sodium is the spectator.
Spot on. It's not, the sodium ion is not reacting, so we don't write it.
So in all of the cation ones, it's only the hydroxide reacting.
Yeah, or you'll see some others where it's not hydroxide, but it might be the ammonia complexing, or the thiocyanate complexing, or the iodide reacting. Okay, so I've done that one there. I'm now going to get another one just to see what happens. I might need to rinse some of those out. Choose that one because I like doing this experiment. Okay, so a little bit of this one. Again, it's a colourless one, so it's not copper, it's not iron 2, it's not iron 3. The first step is always a couple of drops of sodium hydroxide. And it goes cloudy. Well, very cloudy. Okay? So again, it's lead, aluminium, zinc, or magnesium. Now if I go excess of this, that cloudiness disappeared. So now it can't be magnesium. It has to be aluminium, or lead, or zinc. Okay? It says in my thing to get a new sample, so I will. I should get the right one, otherwise I'll be really embarrassed. Put it. Oh, there it is. Sorry. And for this one, it says to add some iodide. Again, in this case, it would be potassium iodide. So I'm going to do that. A couple of drops. And that's quite an obvious change. Yellow suspension, you can see that it's a precipitate. Okay? So that's a positive. That means I don't have to do any more because that tells me the yellow precipitate is lead. So now I have to write the equations for everything I saw. What happened first? White precipitate. So that means the lead, which is 2+, reacted with the hydroxide of sodium hydroxide to make this precipitate. Then what happened to that precipitate? It dissolved. Good. So PbOH2 reacted with more hydroxides. Now you need to learn the names of the formula, not the names, the formula of the complex ions. For lead with hydroxide, it's 4 hydroxides. So PbOH4. Now 2+, 4- means the overall charge will be -2. Okay, we've still got one more thing to do. What isn't balanced in there?
How many?
Hydroxides. So I need to put my 2 there. That is one of the biggest mistakes in the internal. People forget that one. They do everything else right and they forget that, and it costs them getting excellence. Right, any questions at this point?
So do we have to memorise that for lead it's OH4?
Yes, and for aluminium it's OH4, and for, what else do you have? Zinc, I think, don't you?
It's OH4?
It's OH4. So seeing a trend?
Well, yeah.
Okay, so it's not hard to remember them.
Oh,
Zinc.
okay.
Can you explain again how you got that charge outside the square bracket?
Yes, I can. Okay, lead is 2+.
Yep.
Each one of those is -1.
Yep.
So
okay.
2 minus 1 minus 1 minus 1 minus 1 equals -2. Yep.
What? Say that again.
So that's 2 is 4 minus 1s. So it's
Oh, it's -2.
2 minus 1 minus 1 minus 1 minus 1.
Yep.
If you do that on a number line or in a calculator,
Yeah,
you'll
yeah.
get it to Alex.
Is that why Mr. French says, if not sure, guess 4?
Yes.
The majority of the time it's
Spot on. There's only a couple of exceptions.
Which
Okay,
are?
when I
Do we
do
need
complex
to know?
ions, I'll go through those with you.
So why are there 4 hydroxide ions instead of, I guess, 3 there? Because in the, it makes sense in the aluminium one because there's, on the other side of the arrow there's 3 there, 3 on the
+1.
OH
There's
and then
4
plus
there.
1.
You got 1, 2, 3, 4.
Yeah, but without the 2, like, there wouldn't be, how come,
Right.
like, how come
it's
it,
just that's the stable arrangement of the
So just-
hydroxides
Oh,
for that
okay.
ion.
So is it just because?
Basically, yes. Okay. That's probably the easiest way to answer that for now. I'm sorry. We're still missing one observation, so I'll just move on to that so we can finish here. And that was the lead reacting with which ion in the potassium iodide?
Iodine.
Iodide. Great. Because it's in group 17, it's got a 1- charge. Remember how to use the periodic table for that. So to balance that, that must be PbI2. Another common mistake in the internal is to not balance the charges there. Just write PbI because it, for some reason, it looks right. PbI2. Okay? So what we've got there are examples of observations being justified with equations. Making sure they're balanced, and if they are complexes, making sure we've got them written out with the correct charge. Okay. I'm going to leave it at that, and then go through some more if people would like some examples of them here. So I'm going to stop there.